Hi everyone, hope you're doing well. This is a video to go over the miscellaneous review packet number 116. So basically these are just some questions that I picked out from the last two packets that we did, which were day 1 to 7, and then your part 2s, which would have been day 8 to 14, just the ones that I thought were most important I wanted to go over again. So please make sure you post all of these pages for me on Google Classrooms. You get credit for the assignment and your classwork, and very, very exciting. This is actually your last video for the year. So nice job. I'm so proud of you. You guys worked so hard. Thank you for doing all of it. And we got this last one to go. So let's just finish strong. All right. So here we go. All right, question number 1. Give the ordered pair that represents the solution of the following systems of equations. So whenever you have two lines that intersect, your solution is always going to be the point where the two lines intersect. Two lines intersect. So that would be this dot right here, this point. Your x value is 3, your y value is -2. So 3, -2 is your answer. You're going to see, by the way, again, that these are going to be part 1s and part 2s that you've done already. So. All right, number 2a, find the sum of 8.46 times 10 to the 6 and 3.1 times 10 to the 6 and write in scientific notation. So this should look familiar. All these questions should look familiar. Okay, so sum means to add. So most important is you have to make sure you have the parentheses. Okay, that's so important. So I'm going to write here, must use parentheses. So important. Okay, so you want to make sure that when you're putting into the calculator, you have those parentheses. So open parentheses, 8.46 times 10 caret 6, and then you have your plus sign, 3.1 times 10 caret 6. And we want this in scientific notation. So by now, you know you're going to press the second button, DRG, and then move over to SCI. So second, DRG, move over to SCI, obviously press equals, and then we copy this answer, 1.156 times 10 to the 7th. All right, part B. How many times greater is 6.24 times 10 to the 8th and 3.12 times 10 to the 2nd? And this one they want it in standard form. Okay, so how many times? That's the tough one. Okay, times means multiply, but how many times actually means to divide. So you're going to divide these two. And so important, you want to make sure that you put the bigger exponent first. Okay, bigger exponent must come first. Okay, because if not, then your answer will be wrong. And again, you want to make sure that you use the parentheses. So 6.24 times 10 to the 8th divided by 3.12 times 10 to the 2nd. And again, I'm going to write must use parentheses. And this time we are in standard form. So you're going to go back to that second DRG, but now we're going to move back to flow, and then we're going to press equals. Okay, so most important, parentheses. Open parentheses, 6.24 times 10 to the 8th divided by, again, notice I put the bigger exponent first, okay? Parentheses, 3.12 times 10 to the 2nd. And we have our number in scientific notation. We want standard form, so second DRG, move back to flow, press enter, and there we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it looks like we have 2 million as our answers. Hopefully that one wasn't too bad. Okay, number 3. Find the ordered pair that represents the solution for the following system. Okay, so this is actually the question that you guys had on your multiple choice. And this is the one that had the additive inverses. Okay, these are additive inverses. Remember, additive inverses are numbers that are the same. See how they're both 3, but one's a plus and one's a minus. So we need that in order to do this question. So additive has the word add in it. So you're going to add these together. You're going to combine your like terms, okay? So 8x and 2x get you 10x. A positive 3y and negative 3y, because they're additive inverses, they cancel each other out or eliminate, okay? And actually, in the high school, they actually call this the elimination method. They say that or the addition method. But for now, we're going to call it the addition method because there's additive inverses. So those cross out, bring down your equals, combine your constants. 5 plus 5 is 10. And then we finish by dividing both sides by 10 and get x equals 1. But we can't stop there. We have to keep going. We have to get the ordered pair. So we need the y value. So the first thing we're going to do is we're going to rewrite the original equation. That's really, really important. So must rewrite the original equation, because you have to have an equation in order to plug in. Okay, so what you're going to do is take this value right here, this x value that you just figured out, and you're going to plug it in place here and substitute it. And make sure you use parentheses when you substitute. So 1, and then copy the rest. And now we're going to simplify. 8 times 1 is 8, plus 3y equals 5. Now it's just a two-step equation, so move over your constant. This is a positive, so to the opposite. Negative 5 minus 8 is negative 3. Divide both sides by negative 3. And y equals negative 1. So basically you put those two together, 1, negative 1, and you come up with your solution point. So again, you have additive inverses. We add them together by combining your like terms. That got us 10x equals 10. Divide by 10x equals 1. Plug that 1 into here. Simplify, got y equals 1, and put them together and got your coordinates. Question number 4. This was your systems of equations question. That was your part 2, okay? And what you had to do is you had to take this expression right here, and you had to plug it into the one above it, into the place of y. So again, this should look familiar. This is what we've been doing. So bottom expression always gets substituted into the top equation for the y. Okay, so bottom expression gets substituted into the top one in place of y. Okay, so here we go. So you're going to write over the top equation the one that you're plugging into. And again, I'm going to plug it in for y. So make sure you use parentheses. So negative 3x minus 1 equals 6. I'm going to write that. Must use parentheses when substituting, because that's really going to help you out, okay? Then we're going to do our distribution, DCMS, doing complicated math stinks. Distribute, combine, move, and solve. Okay, so first, we're going to distribute. We have to multiply. So you're going to multiply what's on the outside. So 4x plus 2 times negative 3x is negative 6x. 2 times negative 1 is negative 2. Okay, next, you're going to combine what's on the same side. So any like terms on the same side, those get combined. So 4x plus negative 6x is negative 2x. Move, you usually move a smaller variable to larger, but we don't have variables on both sides, so we're good. So regular solving, 2 steps. So do the opposite, add 2 to both sides, and you get that's 6 plus 2 is 8. Divide both sides by negative 2, and x equals negative 4. Okay, now you want to solve for the y. So you're going to take, I usually make you use the bottom one, it's just easier. Take this x value, and now plug it in place of x, okay? And when I simplify, that gives us 12, which gives us 11. So our equation is negative 4, or excuse me, our solution point is negative 4, 11. And you could go back and plug it in to check. All right, number 5. So this is our one, that's our 2 equations, okay? We have y equals x minus 2, and y equals 1/3 x plus 2. And you know we want to graph it, and then we want to do give the solution, which is what we always do. Okay, so again, the solution, let me write a little bit of notes first, is point where the 2 lines intersect, okay, and very important, don't forget to label the axis with the numbers and the line with the equations. Okay, so let's bring down our 2 equations. Okay, we have our y equals x minus 2, y equals negative 1/3 x plus 2. We have our 2 linear equations. Let's label our axes. Remember, in the high school, they allow you to do 1 box equals 1 unit, so I allowed you to start doing that. If not, you can label like this. 5, 6, 7, 8, 9, 10. So to the right and up are your positives. Negative 5, negative 10, negative 5, and negative 10. Okay. So what do we need? We need the m and the b for each one of these. That's what allows us to graph these, okay? Remember, each equation is y equals mx plus b. So your m is the coefficient of x. There's no coefficient here, so we assume it's 1. Make it a fraction by putting it over 1. Your y-intercept is that constant, okay? M stands for move, and b stands for begin. So you're going to begin on the y-axis. So this is where you're beginning, okay? So look for negative 2 on the y-axis. Since it's a positive slope, you want to move up and to the right. So up one, right one. Okay, up one, right one. Keep following that pattern. It's a constant rate of change. Go back to here. Down one, left one. Down one, left one. Okay, then you have your straight edge. Connect those dots. Make sure you have arrows on the ends. You write that. Must have arrows. Okay, and then like I said over here, don't forget to label with the equation. So y equals x minus 2. So that was this point, or that equation right there. All right, next one. Again, mx plus b. So slope is the coefficient, and then your y-intercept is your constant. So this stands for move, this stands for begin, and again, you always begin on the y-axis because, well, this is called a y-intercept. So you're going to start on the y-axis. This time we're beginning at positive 2. And since it's negative, we're going to move down. But remember, you always move to the right, right? Whether it's positive or negative, you're going to move to the right. But instead of moving up, we're going to move down. Okay, so here, we're going to move down 1, 1, 2, 3 to the right. There is your answer, okay? Down 1, 1, 2, 3 to the right. Down 1, 2, 3 to the right. And then up 1, 3 to the left, up 1, 3, up 1. Okay. Remember, they should intersect at one point. Otherwise, that's how you know you did it wrong. Okay, so arrows again. This was your second equation, or your second line. The equation is negative 1/3 x plus 2. And then we have right here our solution point, and our solution point is 3, 1. So I'm going to write that over here. All right, so again, we did the M and the B of each one. We labeled the axes. We plotted both of the lines using the M and the B, and then we found the solution point where they intersected. So that question is done. All right, number 6. This should look familiar. Emma saves the same amount of money each month in her bank savings account. The amount of money she saved after different numbers of months are shown. So rate of change, y-intercept, and equation. The same thing that I had you do the other day. So rate of change, again, is fancy for slope. So to be consistent, we always use our first 2 points. So 2, 500 and 4, 1500. So you have x1, y1, x2, y2. Those are the ones they come first. Those are the 2s they come second. And you have your formula, y2 minus y1 over x2 minus x1. Okay, so y2 is 1500, y1 is 500, x2 is 4, x1 is 2. So 1500 minus 500 is 1000, 4 minus 2 is 2, and you divide them and you get 500. So my slope is 500. Okay, for the y-intercept, I'm going to use the slope and the first coordinate. That's how we're going to always be consistent, okay? That's what we always did in class. So you have your x and your y. And you have the slope that you just figured out right here is 500. And this time, instead of plugging into this formula, we plug it into the general formula for the equation of a line. So y is 500, m is also 500, x is 2. Again, we always multiply, so that's 1000 plus b, and then we subtract, and we get negative 500 equals b. So we had a positive 500 for the rate of change, and we have a negative 500 for the y-intercept. All right, so now we need mx plus b form. So m from above is 500. B from the second step is negative 500. Put them together, and you get your equation. Y equals 500, x minus 500. And number 6 is done. All right, number 7, we're going to graph a line segment that has those coordinates, and then we're going to find the length, and then between which 2 consecutive integers does this lie. So hopefully looking at this question, you already know, oh, I've plotted these points. I'm going to create a right triangle, and I'm going to use the Pythagorean theorem. Okay, so let's see. Let's write some notes first. So graph and create a right triangle, and then label the axes with the numbers. Okay, so let's start there first. Remember, you could do 1 box equals 1 unit in high school. I'm just going to do this, get this out of the way. 6, 7, 8, 9, 10, 5. Remember, these are your negatives to the left and down. Okay. So plotting points. Negative x is to the left, negative y is down. So let's go left. 1, 2, 3, 4, 5, and then down. 1, 2, 3, 4, 5. Okay, that's important too. Label points with capital letters. Label points with capital letters. Okay, x is positive to the right, y is positive up. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Okay, so what you want to do now is you want to use that straight edge again, and you want to connect these dots. And then essentially what you're going to do is you're going to make that right triangle, okay? So what you do is you bring this line down, and you bring this line straight over, and then where they intersect, put another dot, and that's going to create your right triangle. And then what we do is we always count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So actually don't really count the boxes. You count like right here where you see the 4 grid lines intersect each other, one jump. That's really what you're counting, okay? So down here, 1, 2, 3, 4, 5, 6, 7, 8. All right, so it should be 12 and 8 because you can count horizontal and you can count vertical, but you can't count diagonal. That's not allowed. All right, so what we have is we have our right triangle. Use Pythagorean theorem. Remember that is a squared plus b squared equals c squared. And your C always has to be the hypotenuse, okay? So C must be the hypotenuse, okay? A and B don't matter. They're interchangeable. So A, we're going to make 12, so 12 squared. B, we're going to make 8, 8 squared. But this has to be the same, okay? 12 squared, remember, you should put the squared button in the calculator. So 12, and then your squared button is here to the left of the 7. So 12 squared is 144. So that's 144. 8 squared is 64. You're going to combine your like terms. You're going to get 208. Now, we don't want c squared. We want c. So to do that, we take the square root of both sides. Remember, second x squared is how you're going to get this square root symbol. Okay, so let me clear this out. Second x squared, 208, and we want nearest tenths. So look at the hundredths. Look at the second number. And the second number does not raise that up, okay? That's 4 or less, so let it rest. So it's going to be 14.4. So C equals 14.4 units. All right, then it always asks you which 2 consecutive integers does this lie. So where would you lie? If you had a big number line, where would you plot 14.4? So it's going to be between, okay, so think of even like $14.40. Like, what is that in between? Between 14 and 15. It's always, always, always this number. You copy it over, and then you do the next consecutive number. All right, question number 8. Triangle CAT has the following vertices. So that's the original one that's right here. Okay, 3, 1, 7, 6, and 8, 2. So now we want to graph triangle C prime, A prime, T prime. And that's going to be our image. That's going to be reflection over the y-axis, okay? So actually, before we even start with any, let's make sure we always label, all right, this is important, label the axes with the numbers. So, you know, in the high school, you could do 1 box equals 1 unit, but I'll also label the numbers, 6, 7, 8, 9, 10, for those that want to do it this way. Negatives to the left, and negatives down. Okay, so we have our original, and we want to reflect it over the y-axis. So this is going to be our middle reflection line, okay? And then there's 2 different ways to do this. The first way is the rule way. So your rule, when you're reflecting over the y, is to change the sign of the x coordinate. So we'll do it this way first, and then I'll show you the counting way. And then don't forget, once we make the letters, we want to label the letters with primes. Okay, it's really, really, really important. And actually, I'm going to write over here also, super important, is you want to label the points. So when we put these letters on, they have to be capital. Okay, so label the points with capital letters. Okay, so here we go. So we're going to look at all the x values, the 3, the 7, and the 8, and we're going to change those signs. So positive 3 is going to become negative 3. Keep the y the same. Positive 7 becomes negative 7. Keep the 6 the same. This becomes a negative 8. Keep the y the same. Okay, so now let's graph these. So anything to the left, or anything negative is going to be to the left on the x, and these positive y values are going to go up. Okay, so -3 to the left, 1 up. That's C prime. You got a capital letter and you have a prime. 7, 1, 2, 3, 4, 5, 6, 7, and 6 up. 1, 2, 3, 4, 5, 6. That's A prime. 3, 4, 5, 6, 7, 8. 2 up, and that is T prime. So use your straight edge and connect your dots to make your triangle. And that is the reflected one. Okay, so just going to remind you how you could have done this the counting way. So remember, reflection just means the same distance from this line of reflection, this middle line, this mirror line. So if C is 1, 2, 3 to the right of it, you go back to the middle, and it's 1, 2, 3 to the left. A, 1, 2, 3, 4, 5, 6, 7 to the right. So you go back to the middle, 1, 2, 3, 4, 5, 6, 7. You're just going to go the opposite way. And then for T, 1, 2, 3, 4, 5, 6, 7, 8 to the right. Go back to the middle, 1, 2, 3, 4, 5, 6, 7, 8 to the left. Okay, so it's a mirror image. It's the same distance from there. So that's how you do it the rule way, and that's how you can also do it the counting way. But either way you do it, you get those same exact points. Okay, so now we want to graph a new one, a double prime. That's how we say that. The image of triangle CAT. So that's this one right here. After translation of 1 to the left and 2 up. So translation is going to be a slide, and we're going to go this amount, 1 to the left and 2 up, okay? And then really important, just like this one over here, you want to make sure you label the letters with double primes, okay? Now double, this one had single, this one had double. So translation is just a slide. Remember, your reflection is a flip, and this one is going to be in opposite direction. Okay, that's what you can see right there. Opposite direction. Slide is going to be same direction, by the way. All right, so here we go. So start with C prime, right, because that's what we're removing. We're going to go 1 to the left and 2 up. So that's going to be C double prime. So let's do that coordinate. So 1, 2, 3 to the left. Wait, 1, 2, 3, 4 to the left. 1, 2, 3 up. So 1, 2, 3, 4. So -4 to the left, and then 3 up. So 4 to the left is negative, 3 up is positive. All right, so now we're going to go 1 left, 2 up again. So 1 left, 2 up. So that's a double prime. 1, 2, 3, 4, 5, 6, 7, 8. That's going to be to the left. That's negative. 1, 2, 3, 4, 5, 6, 7, 8 up. That is positive. All right, so now T, we're going to go 1 to the left, and we're going to go 2 up. 1, 2. And we're going to T double prime. 1, 2, 3, 4, 5, 6, 7, 8, 9. To the left, that's -9, 1, 2, 3, 4 up. So -9, 4. So -4, 3, right? 4 to the left, 3 up. -8, 8, 8 to the left, 8 up. And then -9, 4, so 9 to the left and 4 up. So let's use that straight edge. And let's connect these dots, okay, to create our triangle. And this was our double primes. And there you go. So that's basically it for this one, okay? So again, we did the reflection, which is the flip, right? This one basically just got flipped over. And to do that, either you do the rule, which is change the sign of the X, right? Reflect over the Y, change the X. Or you could do the counting way. And we got all of those coordinates. And then we did a translation. So we moved the orange one, right? Because that's this one right here. We moved the orange to create the pink. Each one of those, we just went 1 left, 2 up. Let me start with C. 1 left, 2 up. A. 1 left, 2 up. T. 1 left, 2 up. So that's how we created C double prime, A double prime, and T double prime by moving the C prime, A prime, and T prime. And that got us -4, 3, -8, 8, and -9, 4. And you can see on the graph how the orange triangle just slid up to get the pink one, and that is your translation. So, all right, just make sure you label the axes with the numbers, label the points with the capital letters, and yeah, I think this one is all done. Okay, question number 9. Write an equation for a line that passes through the points 8, 2 and 0, 7. This is actually on your multiple choice portion. What was nice is that if you notice every single time, I always gave you the y-intercept, okay? And you knew this was the y-intercept because the x is 0, okay? So when you come over here, to do your work. Okay, you automatically can put that y-intercept of 7. Okay, so this is the one where you do our formula. M equals y2 minus y1, x2 minus x1. Don't forget this is x1 and y1, and x2 and y2. So y2 is 7, y1 is 2, x2 is 0, x1 is 8. So 7 minus 2 is 5, 0 minus 8 is negative. Even when you write it and when it's typed, that negative is always on the outside. Never put in the denominator, okay? So come and bring that number over here. And then let's make our final equation. Y equals negative 5/8 x plus 7. So the slope always goes with the x. The y-intercept is always your constant. And again, you should have noticed that every time on the multiple choice, you always were given a fraction that did not simplify. So, all right, number 10. This one's definitely a little more difficult than what you have been getting and what you will get this year, but why not? Let's just try it. In which interval is the following graph increasing? So let's just try a tough one. You guys can do this. So increasing is positive slope. Now notice it doesn't say linear, and it says that for a purpose. Because actually this portion right here, okay, let me write these out. 1, 2, 3, 4, 5. That's going to help us. This portion is increasing. Okay, it happens to be nonlinear, but it is increasing. Okay, and this might help you for more in high school. So from x equals 2 to x equals 3. So we're going to write between x equals 2 and x equals 3. That's where we have our increasing. Okay, our next one is we want decreasing. So decreasing, remember, was our negative slope. Our positive slope goes this way, negative slope goes this way. So which way looks like it's going down? So it's actually from here to here and here to here. So this happens to be nonlinear. Remember, nonlinear means a curve, not a line. Remember, not linear, not a line. But it is decreasing. Okay, and this one over here is linear because it's a straight line, and it is also decreasing because the y values are decreasing. They're going down, okay? So we have between 1 and 2. So let's start with there. So between x equals 1 and x equals 2. And now we're going to go from here 3 to 5. And between x equals, what did I say? 3 to 5. X equals 3 and x equals 5. So again, this one's a little bit more difficult, but I know you guys can do this. In which interval is the following graph decreasing? Okay, so that's this. And linear. Okay, remember, so this is all nonlinear because it's a curve. This is the only portion right here that is linear, and that happens to be the portion that is also decreasing. So decreasing was your negative slope, so we're looking for something that goes this way, and linear, we're looking for straight line, and that's the section right here. So the 3 to the 5. Remember, we always, whenever we do this kind of question, when you do this next year in your high school course, you're always going to describe it with the x value. So 3 to 5 between x equals 3 and x equals 5. So that was a tough one, but I think you guys are okay. All right, circle which one represents a function. Remember, oh, relation, so it could be more. Wow. Okay, so remember, in order to be a function, it is when the x values do not repeat. Okay, x values don't repeat. They can be tricky and give you this, but the y values can. Okay, sometimes they make the y values repeat, and that is actually okay. Okay, so we're looking for where the x values don't repeat. Right, what's a function? So 4, 2, 8, 4. Nope, you heard me say 4 twice. That one is no good. All right, B, 7, negative 2, 8, 4. That one looks good to me. None of them repeat. All right, again, 7, negative 2, 8, 4. Nothing repeats. Negative 1, 0, 5, and 6. I don't think I heard anything repeat there. Right, negative 1, 0, 5, and 6. That's good. Negative 2, oh, well, that one's no good, right? I said negative 2 right away, so that's no good. 1, 6, negative 1, 2. All right, that sounds good. 1, 6, negative 1, 2. And then one more. 9, 8, 9. Oh, the double nines, no good. So this one happened to have 3 answers. But if you ever took this on a test, it would always have 1. Okay, 12. The equation of the line y equals negative 4x minus 5. Which point lies on that line? So this is the one on your multiple choice that you did guess and check for me. So you're going to guess and check the coordinates. Guess and check coordinates by plugging in the x and y values. And then we're going to simplify, obviously. But all right, so let's start with the first one. So we're going to start with -3, 5. This is my x and this is my y. I'm just going to go right in order. I just always think that's the better thing to do. I'm going to copy this equation. Okay, so I'm trying this one first. These are all my x values. These are my y values. So y is 5. X is -3, so I'm going to simplify. This stays as 5. I'm going to multiply those two numbers to get 12. And 12 minus 5 is 7. Well, is that true? Does 5 equal 7? No, it doesn't, so that answer is no good. All right, next one. -2, 3, x and y. Y equals -4x minus 5. All right, let's try this one. So y is 3, x is -2. -4 times -2 is 8, and 8 minus 5. Oh, look at that. We have an answer. They are correct. So you have the correct answer. You know it is correct when those two constants at the end are equal to one another. All right, last page. You guys are almost done. Let's keep it moving. You guys are doing a great job. All right, so we want to solve for A. So you've done these before. You know, this is the one I always tell you, just the 3 buttons that they always think you're going to forget. So they always have you do this question on the test, on the final. So you are taking the cube root. So it looks like a square root with a little 3 because it's the opposite of cubing something. And those 3 buttons, hopefully you remember them. 3, second, caret, we're going to put in 512, and then we're going to press equals. So I'm sure you guys could do this. So 3, because you're doing that root, so 3. Second, which is right here, caret button, which is your exponent button. Remember, you'll see that little x there. That's how you know you did it right. 512 is the number we want, and then press enter, and you get 8. So A is 8, and that's because 8 times itself, 1, 2, 3 times, is 512. That's how you know. All right, 14. Mr. Smith is buying 2 types of gift cards to give his prizes to employees at a company meeting. He will buy restaurant gift cards. Okay, that's our first type. So restaurants, so all these ones are $35. So this is 35, 35, 35, and 35. Okay. Then he's also going to buy movie theater gift cards that are 20. So all of these ones right here, those are going to be your $20 ones. And in total, he's got $360. That's what we want the total to be. And you know, to do this one, you're going to guess and check. Okay, this is a systems. This can be done the systems way. I think for you guys, it's just much easier to do. Okay, so we're going to start here. 8 restaurant gift cards at $35 a piece. So it's going to be 35 times 8. Okay, 35 times 8 is going to give us $280. And then we're going to move over here. 4 movie theater gift cards at $20 a piece. So 20 times 4. That's going to give us 80. So we're going to add the 2 of them together. We're going to see what we get. So 280 plus 80. Okay, let's see. We have 280 in here. Plus 80 is going to give us 360, and that's actually what we need. We need 360. So yeah, we got it right on the first try. So our answer is going to be choice number 1. All right, 15. Which of the lines below has a slope of 0? So think back to your slope dude. Which one was he saying? This is 0 fun. This is 0 fun. This is 0 fun. Hopefully you chose this one. Okay, you're looking at this line. These are the lines that you're looking at right here. So this was a 0 slope. This was positive. Remember, going uphill. Downhill was negative, and this was falling off the cliff, and that was undefined. Okay, so this one is going to be your 0 slope. All right, we made it to the last question. Yay, of the last video of the year. All right, ending with the tough one. Let's see. Here we go. Which sequence of transformations All right, so we made it to the last question, yay, of this packet. So exciting, and it's a tough one, but here we go. Which sequence of transformations maps figure 1 onto figure 2 and then figure 2 onto figure 3? So it's always the same stuff. You guys notice A, B, C, D, A prime, B prime, C. So they're in the same exact position. So this was just a slide. Okay, figure 1 to figure 2 was just a slide. Remember, slide, you know, is translation. Okay, then from 2 to 3, what happened here? 2 to 3, notice it got turned on its side. Okay, so 2 to 3 is a turn. So slide is translation, turn is rotation. So we want translation, then we want rotation. Okay, so again, translation is just a slide, rotation is your turn. So translation is when it's the same shape and size. Same shape and size. Let me write that over here. And then this is the same direction. And then rotation, that's also the same shape and size, right? Notice none of these changes size at all, but this one is, I guess you could just consider like a turned direction. So that's what it's going to be. All right, so 16 is D. All right, so that is it. You are officially done. So exciting. Please make sure you post all these pages for me on Google Classroom so you get credit. If you have any questions at all, please reach out to me. But you did it. You guys are done. From here on out, you just have a couple more Google Forms tomorrow to do and next week and a quizzes. But that's it. No more videos and no more writing all this work for me. So thank you again so much for doing all of this. I really, really appreciate it. I hope you guys got something out of it. And yeah, that's it. Have a great day. Take care.